A steel wire having cross-sectional area 1.2 mm square is stretched by a force of 120 Newton. If a lateral strain is 1.455 mm is produced in the wire, calculate the Poisson's ratio. Take Y of steel is equals to 2 into 10 to power 11 Newton per meter square. So basically we have to calculate the Poisson's ratio, or we know the formula of Poisson's ratio: lateral upon linear, that is lateral strain upon linear strain, and the lateral strain is given 1.455 mm, but the linear strain is not given. Therefore, with the help of cross sectional force and Young's modulus of a steel, we can calculate the linear strain of a given material. Therefore, first I am writing the given data. The first area of cross section is given, so cross sectional area of a steel wire is 1.2 mm square. Now the Young's modulus of steel is given in terms of Newton per meter square, so I am converting each and every dimensional or a unit into a meter. Therefore this is 1.2 mm square is given, so I'm just converting it into a meter, that is 1.2 into 10 raised to power minus 6 meter square. Second, the force is given, that is F 120 Newton, and the lateral strain is given 1.455 mm. We know lateral strain of wire is 1.455 mm. I am again converting it into a meter, 1.455 10 raised to minus 3 meter. And last one is Y of steel is given, that is 2 into 10 raised to power 11 Newton per meter square. Find Poisson's ratio. We know Poisson's ratio, it is denoted by sigma. Formula, we know Poisson's ratio is equals to lateral strain upon linear strain. If I am calculating a linear strain and I have a lateral strain, then with the help of this formula I can easily calculate Poisson's ratio. Therefore, solution, we know linear strain is equals to a stress upon Young's modulus. Therefore, E is equals to, stress is equals to force upon area, that is force upon area into a Young's modulus. Therefore, E is equals to, I have force of 120 Newton and area is given 1.2 into 10 raised to power minus 6 into Young's modulus also given 2 into 10 raised to power 11. Therefore, E is equals to 120 upon 1.2 10 raised to power minus 6 into 2 10 raised to power 11. So I got E is equals to 5 into 10 raised to minus 4. Now I got linear strain, that is change in length upon original length, and I have a lateral strain, so I can easily calculate Poisson's ratio. I have a lateral strain, that is 1.455 mm, and the linear strain is 5 into 10 raised to minus 4. Uh, Actually there is just some typing mistake in your textbook from where I'm taking this numerical. Here actually it is, the lateral strain is 0.1445 mm. So I'm converting it into a meter, that is 0.1455 10 raised to power minus 3 meter. Now we have lateral strain, that is 0.1455 into 10⁻³ meter, and the linear strain is 5 into 10⁻⁴ here. So I can easily calculate the Poisson's ratio denoted by sigma is equals to lateral strain upon linear strain. That is, I have lateral strain 0.1455 10⁻³ and linear is 5 into 10⁻⁴. Therefore 0.1455 10⁻³ upon 5 into 10⁻⁴. Therefore Poisson's ratio is equals to 0.291 is my final answer. Actually, the value of lateral strain in your textbook is given 1.455 mm, and if I am taking this much value, that is 1.455 mm, for calculating the Poisson's ratio, then मुझे मिलेगा 2.91. But we know, as per the derivation and the theory of Poisson's ratio, it will always lies between -1 to 0.5. It means the Poisson's ratio should not greater than 0.5 and should not be lesser than 0.1. इन केस आपके बुक में जो लेटरल स्ट्रेन का वैल्यू है 1.455 mm वो मैं लेता हूँ तो मुझे यहाँ पे वैल्यू मिलेगा 2.91 and that should be greater than the limiting value of Poisson's ratio.